Good morning, good morning, good morning, good morning. Good morning. This is a audio test for the Robothon broadcast on the first day. It would be nice at this time to get some feedback.
Hello.
I mean feedback in, can you hear us? Yes. Can you see the screen? Yes. And, sorry. Peppy and Corky. Toot toot, boing boing. And we can switch the audio off. De eerste. Yes? Okay.
Ladies and gentlemen. Zo niet, hè? With us today, and we very much appreciate your presence here. Ja? Mag zonder.
Staat deze aan? Staat die aan? Ja. Good morning. Good morning. Hello. Who is that about? Hello, good morning. Welcome to the 5th edition of Robothon. We have a busy schedule already. I would like to speak or like to talk a little bit about some of the logistics in a bit. But first of all, I'd like to introduce you to our director of the school, Mika Schumacher, who will say a few words to you first. So, Mika.
Ladies and gentlemen, I wish you a warm welcome to the Royal Academy of Art. You've come from all over the world to be with us today, and we very much appreciate your presence here. Today and tomorrow we are hosting the 5th Robothon Conference. The Robothon Conference on font software and font technology is organized by our master degree program TypeMedia. It is coordinated by Erik van Blokland and Paul van der Laan. I would like to take this opportunity to thank them for all their efforts to make this conference a success. And we can indeed speak of a success. In 1999, we held the first ever Robothon conference, at which around 30 people were present. This time we have 180 participants, and the tickets sold out within 1.5 hours. This is also the 4th occasion on which the Robothon Conference is taking place, alongside the awards to the Gerrit Noordzij Prize. The Gerrit Noordzij Prize is awarded every 3 years to a person who combines the practice in type design and typography with teaching and research. While there are awards for excellence in each of these disciplines individually, the Gerrit Noordzij Prize acknowledges the combination of disciplines. The prize will be awarded tomorrow to Cyrus Highsmith. For this moment, it is a particular honor to announce that 2 previous winners of the prize are present here today. Fred Smeyers and Tobias Freer-Jones. Where are you? I already mentioned that you had come from all over the world to be with us. Also present at this conference are representatives from technology businesses, including Adobe and Microsoft, and representatives from all the major type foundries, such as Font Bureau, Commercial Type, Heffler & Co., House Industries, Monotype, and Mersawa. And of course, I can't fail to mention that among you are more than 50 alumni of the Royal Academy of Art, The Hague. Needless to say, we are incredibly proud of that. I will now round off this brief word of welcome, but not before wishing you an inspiring 2 days, filled with great opportunities to make new acquaintances and to take part in boundary-defying exchange of knowledge and experiences. I wish you all a very enjoyable conference. Thank you for your attention.
Okay, thank you, Mika. Thank you very much. So, folks, I only have a few minutes, I guess, to give you a rundown to what we're going to do the next days. Okay, that's me, co-organizer, co-ding, amateur. Sort of also explains why I'm so feeling at home here at this conference. So just a few things about how things work here in the school and during the conference. So you have your badge, well, I hope so at least, with a program on it. So we just try to just keep it as simple as possible. The badge you need to have with you for the conference, but also tomorrow during the dinner, for instance, that's organized. Then bathrooms are actually right next to the auditorium here. If you in doubt, just ask one of the students. There's no smoking in the building already since, well, when I was a student, we were still allowed to smoke, actually, but that's a long time ago. TypeMedia classroom, maybe you've seen it already before, but that's on the other side of the hallway here. There's the a new foosball table we just were able to buy with a lot of help from actually people here in the audience too, which is absolutely fantastic. I'm sure you'll find good use for it during the days. Then we have some breaks, of course, coffee breaks, lunch breaks. We have a fantastic assortment of cookies and cakes and sandwiches again. They will be served also outside here in the hall and right next to it on the right-hand side. So you can get also some coffee there. There is an espresso card actually sponsored today by Heffler & Co. and tomorrow by Adobe TypeKit. So if you want to have like some real good coffee, then you can also do so. For the rest of you, there's also coffee and tea and also here in the hall. Then, yeah, if you need something else, the cafeteria is a little bit further here in the building. You passed it already when you came in. So if you need some other snacks, there's the place to go. By the way, this is an art school. You don't want to know how actually, well, the auditorium was in a pretty good state still yesterday, but the rest of the rooms here, we had to clean a lot of stuff. And I wouldn't be surprised if maybe if you come in somewhere during the day, something else might have popped up. An art installation or something that you might not really fully grasp at first, but it's probably, it's art, exactly. Be very gentle, be very, just go around it if necessary. Don't be annoyed by the students making it. Then we have some extra t-shirts left. You could already, of course, buy some at the registration, but we have only, well, few still left. If you want to buy some, they're at the registration desk. They cost 25 euros. Then, yeah, you might want to get online. This is probably not enough time for you to write it down, but maybe it's best to remember KABK Wi-Fi for all. That's actually what it says here. We'll put up some extra signs also in the hall to repeat this. So if you need to get online, this is the way. So the program, yeah, yesterday we started already a Python workshop with Guido van Rossum and Frederik Berlijn. That was an extra. Basically, what we did 9 years ago for the conference was 40 people in one room. That was exactly the room where we did the Python workshop yesterday. Today we have, well, first of all, a speech by Peter van Blokland, Extrapolate. We have talks about tools, about Mutator math, UFOs. Tel Lemming will also explain more about his developments. TrueType hinting by Jeremy Hornus and his brother. Then tonight, after so we finish here at around 4:30. Tonight at Peter's place in Delft, there's a party sponsored by Font Bureau. Everyone is of course invited. Bring your badge, and we'll sure have a good time. If you need to get to Delft, tram number 1. Also just look at Peter's website and you can get more elaborate directions there. Tomorrow we have more lectures about glyphs, the glyphs SDK, mechanic, the Adobe FDK, and Nick Sherman will be doing a lecture about fonts for responsive design. Then tomorrow we're not finished, of course. We have the Gerrit Noordzij Prize ceremony with the awards being given to Cyrus Highsmith, as already said by Marika, together with the opening of the exhibition of the former prize winner, that's Karel Martens. There's a big exhibition, beautifully done by Jan-Willem Stas and the team of all the students from TypeMedia. You will be there also then tomorrow afternoon for drinks and then the opening. And afterwards we have a dinner on the second floor of this school. And that's for everyone included. So that's also a first for a Robothon. We didn't did that the previous year, so we're really happy we could get this. Now, if you're still then alive, I hope so. I can't vouch for it, but Saturday there will be the Gerrit Noordzij Prize seminar dedicated to Karel Martens. There will be speakers, Richard Hollis, Robin Kinross, Fred Smyers, Roelof Mulder, Peter Bielak, and some others. If you haven't registered yet, sorry. It's already sold out, but I hope you do, you got your tickets. We sent at least an invitation to all you, all the registrants here. So, as a final word, thank you to, first of all, the Royal Academy for hosting us and for being great support in getting this all done. Then, of course, Petter, some companies, Letter, Bold Monday, Type Kids, Heffler, Commercial Type, Font Bureau. Of course, our students of TypeMedia, they are helping out also the next few days. Jan-Willem Stas, of course, for coordinating so much of this event. And last but not least, James Edmondson, alumni of TypeMedia from last year, who designed the logo. So that's it. Am I on time? Now for something completely different. We have.
Hello, letter people. This is Guido van Rossum, and the creator of Python, a programming language named after an old comedy show. It may just be a coincidence due to family ties that you are writing font tools in Python rather than in Perl, but I think you would agree it's a happy coincidence. I'm not sure what else to say except that I wish you a great conference, or hope you had a great one, depending on when Eric gets this video. Oh, and may all your fonts be beautiful, and may all your programs be Pythonic. Take care!
Try? Okay, so Robothon, what is that? Did you explain to your family why you need to fly around half the globe to be at Robothon? And that it's cool, very, very cool, that you actually managed to get a ticket. Before it was sold out one day later. Spending a sleepless night, hovering your finger over the send button to be the first when the ticket box opens. What is it that makes you count down for the 3 years, hoping to be more lucky next time? Hello, remote audience. What is Robothon? It's not about robots. Because that's another conference with the same name in Seattle, October 10th this year. Okay, they have better typography maybe than we have. No, the Robothon is about type. And it's about tools and about scripting and it's about programming. And it's about meeting all these other geeks that found ways to combine all of their activities into a daily job, with the main purpose to fill the space between two Robothons in a useful way. Do you remember this? Well, maybe not. It's a long time ago. This is how it was. And wait. It's faster and it's better, it's using Python, and it's really, really fast. This is just the about box coming up when you start it. It used to be really, really fast. RoboFont is a direct parent of RoboFont. And for those who are coming to the party today, it's there to play with. It's really fun. I'll just wait a little bit to see to appreciate. Anybody ever complain about the speed of tools after this? Think back about this. You know about what type 1 font is? There's Python, 1.3. Open a type 1 font. Generating the bitmap. And mind you, this is only 256 characters. And I think it barely survived because it kept on running for an hour, and after I made this movie, and the screen already starts to disintegrate. I think we're just in time to get this movie done. Do you remember the time when you dragged something, it did not update? Like, see that? You have to wait for that. So whatever happens in the 2 coming days, I hope you appreciate everything that's done in the meantime. I'll post this. It takes a while. Okay, so this talk aims to make more space inside Robothon, to shake up your side bearings and extend your boundaries. A lot of questions will be asked, riddles to solve. A challenge for the other speakers to answer, and for you to calibrate your current style and workflow. Asking questions partly implies the answers. but you won't get them for free. I'll point some directions, but you have to do the math yourself, and to adjust the masters where the extrapolations turn into mayhem. So, what is a typeface? Let's start with the most basic question of all. A typeface is not a folder with files. Type is a set of interrelated glyphs, related by size, contrast, usage, by dimensions, weight and width, association, rhythm, a solution to typographic problems. Why isn't there a hierarchy in... This is not going right, sorry. Okay. We'll catch up somewhere. Why isn't there a hierarchy in components? The ones that are needed for the design process and the ones that are needed in the output format to reduce file size. I think I'm a little bit mixed up. I'm very sorry about that. Huh. Shit. Okay, I'll read. Why isn't there a hierarchy in components? The ones that are needed for the design process and the ones that are needed in the output format to reduce file size. Those are different usages, now implemented as one function. Why are most of the designer's intended relations lost once the UFO is saved and the TTF is generated? In fact, the mere existence of auto hinters, programs that try to reverse engineer the dimensions and relations in the typeface design, proportions that the designer knows everything about, is an example that we're missing structural information in the design and production process of type. It's available at some point, but we simply don't care to store it. Those poor programs, auto hinters, have to guess the designer's intention by looking at the pearl necklace of points, filling dimensions that were lost in translation. Well, all what the program should have done is ask the designer. We need to store the original, not just a pale summary of it. An outline story is never the real story. And so why are... I'm really messed up. I'm so sorry. Shit. Sorry. Looks like I missed some slides. Okay. The existence of fontlib and glyphlib shows the need for tools to store private information. But it's not a good sign that these areas are used to store hinting instructions, stem width and alternative glyph versions, vertical spacing, classes of shapes, due to the lack of a better place. So we want more. Where are the analyzers that give feedback to the designer for tasks that cannot be automated? If you're doing A, don't forget to adjust B as well, because you did that before on the bold master. That's what we would like programs to do. Tell success with the great glyph nanny is only the first proof that programs should talk back to us. Behave like an annoying apprentice, but a damn good one. Why isn't that stored? Oh, yeah, I'm catching up. I'm sorry. Okay, another issue, interpolation. The technique of interpolation didn't change since URW's Icarus and Adobe's multiple masters. For a simple interpolation of one axis, you need two masters, but to extend this to, let's say, a width and a size axis, not an unreasonable request for a type online, a cube of 8 masters is required. If you combine this with the extending glyph sets, features, multiple languages, non-Latin scripts, and if you're aware about the fact that all outlines need a fully compatible structure of points, and that this contradicts with the necessity, with the necessary remove of overlap in certain platforms, and the adjustment to shapes for extreme thin, bold, and narrow, then it easily shows that the design of a complete family expands into an impossible task. So, talking about interpolation, type is not the only thing that you can view in multiple axes. For instance, look at this typical graph that shows the decline of design freedom through the design process, resulting in an increase of production tasks. It's an obvious aim to maintain the freedom as much as possible, but unfortunately, most work in type design is about extending, repeating, verifying, and proofing. So, and then if you extrapolate the production work, it even might go into a design task again. So there's two axes here. It's the amount of design work compared to the amount of production work. What you want is a lot of design work and production work being automated. The practice is that the production work takes most of the time, and the design work is only. And here is where production gets into design again. So, superpolator, mutator math, Eric van Bokland's answers to the linear interpolation limits of multiple masters is an excellent next step. It allows discontinued masters where an interpolated glyph can suddenly change something else. And stress adjustments, bold and black shapes, doesn't work through lighter weights. But what's next? For instance, why are installations still straight lines from one master to another? Our existing tools that allow the user to edit. The details disappear in a controlled manner for small sizes. Many tools focus on the design aspects of type. That is appealing for designers. Designers are visual animals. They want to see images. But a major part of type design is not visible at all. It is about mathematical conversions, about the creation of tables, features, substitutions, adaptations to resolution and render engines, about the execution of hint instructions or the interpolation of blue values or interpretation of blue values. It's about compression techniques, the relation between the available glyph set, the intended typographic usage, the taste of the typographic designer, and the expectations of the reader. There aren't so many tools that give the full support of such a list of requirements. Tools mostly focus on the drawing of type, a little bit about spacing, and from there the designer must assume that the whole process is flawlessly automated under the export menu option. But what do you think that the readers want? Is this the 2 units rounds on the serif added by the designer to express the difference with the design that already exists? A resolution that can never be expressed in the available 256 shades of gray? Or do you think that readers expect the type to be fitting the task, reading in print and on screen, in small body text and in headlines with all optical and format problems to be solved, without any of them knowing about it? What is the supportive tools for that? How can it be that designers are so picky on the details of a curve of their serifs, where at the same time many of them are so ignorant of what their tools are doing during this export conversion process? Here's an example. Why is it impossible to read TrueType and OpenType fonts of files without loss of data? Oh, I know the technical answer to that. The TTF, of course, I should say OpenType with a TrueType flavor using quadratic curves, and OTF, which is OpenType with type 1 flavor using cubic Bezier curves. These formats were never meant to be sources. It was never the intention to open them without the loss of data, manipulate part of it, copy some glyphs from another font, and then save it again, keeping everything else in place and not increasing the original file size. With all hints and features still working. The TrueType, the TTF and OTF files were never made for that. But reality is different. In practice, there are many situations where TTF and OTF needs to be modified and saved without the loss of data. People who think that this is not the case are probably designers without the burden of legacy libraries, linear production lines, and who have total control on their UFO files on the desktops. Decompiling TrueType and OTF into editable data is fundamentally impossible, but for different reasons. I'll drag you through this without images, just to torture you with the idea how difficult it is. The TTF point structure is relatively the most easy one. All points on the outline are available in a table, separate for each glyph in the font. There's some design data missing, like if a tangent point is smooth, you don't know, but that can be interpreted. If the direction of two adjacent lines is within the threshold of some degrees, their connecting point is probably smooth. The problem with TTF is that they have quadratic outlines, and none of the existing tools really like that. So they convert the quadratic outlines to cubic. To some extent, this works pretty well. Just shorten the length of the control points by a factor of 0.77, and then you're all done. But only if there are exactly two off-curve points in the sequence. And only if there's not too much stress on the curves. In extremes, for instance, condensed designs, or if the font has multiple off-curves in a sequence because it was exported, automatic from another tool, then the conversion doesn't work so well. So, thank you, Peter. So the drawing tools start adding points to guarantee the consistency of the curve. Thank you very much. So the drawing tools start adding points to guarantee the consistency of the curve. By adding points, it screws up the relation with the hints. If the fonts get saved again into TrueType. And it increases the size of the font considerably. So the font needs to be rehinted, was originally done manually or automatic, and by which program, and it never gets back to the original file size. It's like disassembling a traditional watch, you'll never get all the parts in their original positions again. Conversions are bad. Conversions lose data. They never will make it back into the original source. Anything that breaks a cyclic design process into a linear process does reduce the amount of design options. Are you still there? For OTF, the problem is totally different. There, the hints are relatively simple, grouped into values that define the overall dimensions of the font. And in OTF, the outlines are the problem. Instead of a table of coordinates, as in TrueType, here the outlines are written as a small PostScript program. And for efficiency reasons, similar parts of the glyph outlines are combined into subroutines. That's not something you ever want to do by hand. Adobe's FDK is doing that, recognizing identical chunks of outline and putting them into pieces of code that are shared by numbers of glyphs. You have to trust FDK in doing the right thing there. But what you know for sure is that the resulting font is different from the original. And it gets worse if the original font contained hinting instructions inside the outline. These are almost sure to be lost in your design application that's opening an OTF file. So, why are so few people yelling for better tools? Why are you so quiet? Tools that solve all of these legacy problems once and for all. It's because these tools do exist, but they are part of the secret application pool of large applications. Are they? Or is it because type designers are so used to their own design space with the comfortable 500 glyphs, drawing Bezier outlines in UFO format, while trusting that everybody else takes care of the rest? Or is it because nobody really bothers? Well, some people do. And a handful. Isn't it strange that all tools for type, a product that everyone in the world is using, is made by only a couple of people? But the majority of them are not even professional programmers from origin. It's like all tools of milk production in the world are made by a couple of farmers, and many of them are Dutch. They didn't even intend to make them. It was merely an accident because they needed the tools for themselves. As a multinational milk producer, I would be scared to death about that. The only reason not to is that those farmers never claimed patents. By putting all specifications into the public domain, everyone can build these tools, make their version, improve and expand. Guido van Rossum, who wrote the Font Tools library to at least solve part of the problem, open and save TrueType fonts without loss of data, donated the program to the world as open source. Font production lines of large corporations, such as Google, are based on them, on this library. Would the world be the same without him doing so? Would someone else have written the same and put it in open source? Maybe, maybe not. Maybe in a parallel universe. Guido van Rossum made Python by far the best choice of language to glue into a design program. RoboFont did it, FontLab did it, Glyphs did it, the FontLab did it, RoboFont did it. Erik van Blokland, Tel Lemming, and just made the definition of UFO with the supporting Python libraries RoboFab, Defcon AppKit, and Vanilla. Adobe donated FDK and Mutator math to the community. And last but not least, PyObjective-C, written by Ronald Usseren, glues Python code on OS X Coca. You're probably unaware of how much type tools are using this glue. RoboFont, Metric Machine, Prepolator, Superpolator, all functions all these programs function due to the mere existence of PyObjective-C. Isn't that scary? If he stops upgrading to the latest Mac OS, the type world really is in big trouble. But doesn't that mean that they give everything away for free? Well, why should they? Besides designing type, making the right tools is a profession too. Not trying to get personal, but if you hear anyone ever complain about the price of RoboFont, Superpolator, Metric Machine, Glyphs, or FontLab, there are two possibilities. Either this someone doesn't get it, that a couple of €100 giving access to years of development and experience offers a gigantic shoulders to stand on. Or this someone expects the tool developer to work for an extremely low hourly rate and thinks that this is good entrepreneurship. Don't be a pussy. Buy them all and complain later. Oh, I know. There are always students and starters that cannot afford the whole package at once. But do you ever hear professional musicians and sporters complain about the price of violins and rowing boats? Crown jewels are costly. Just make it happen. What do we need most? Good drawing tools and platforms, better than we already have, that allow us to create tools that solve the other problems mentioned in this talk. Who dares to extrapolate to what we really need? Why are most tools based on Latin? Test on UFO for 25,000 glyphs and then think again. How about proof in kanji? Pay for the tools that you want, just like you want to be paid for the type that you make. And then there are private tools, things that are down in the closet. I cannot say much about these, but name me one foundry, big or small, that doesn't keep a set of secret tools, not open for sharing. To have so much corporate knowledge embedded that even a simple NDA is not enough to disclose it. Does it sound familiar? I could elaborate on the discussion during ATPI 2013 about the use of Git for version management of UFO files, for instance, but the use of databases would be a much better choice than for selecting and retrieving families, styles, and glyphs that fit a certain set of attributes. SQL is especially made for that kind of stuff. But time is too short to deepen that out, of course. In the whole font industry, if the whole font industry would be rebuilt from scratch, with the knowledge of today and the current computer speed and storage capacity, what would then the difference be with what we have today? Dare to ask these kind of questions. Extrapolation only works with good masters, and if the search is not extended outward too much, but otherwise we need to add new masters. History proves that the future doesn't need discontinued changes in order to be relevant. It does need discontinued changes in order to be relevant. But there's nothing against standing on the shoulders of others to create them. So here's a roadmap for your extrapolated future as a type designer. Make yourself understand what is needed out there and mix it with what you want to make. Don't fall in the trap that because you like it, the rest of the world will like it too. If you cannot make a living from what you're doing, it's not a profession. Maybe it's a good hobby, or even worse, maybe it's art. Understand the process into every detail that may become relevant. And design methods to gather this information. It probably is not available online. It's either locked into the closets of your competitors, or more likely, it never has been fully researched. Define the functionality of your product and then decide if it can be made with any of the existing tools. It probably can't, or else there's a big chance that someone else is already doing the same thing in this small world of type design. If it cannot be made with the current tools, create your own. Build on top of a platform that allows you to use every bit of functionality and data that can be reached inside by your scripts. If your tool is 100% Python, you can make everything you need. And stay independent. Now you do the math. But first, I wish you a very interesting and challenging Robothon conference, and we'll welcome you to the party in our studio tonight. Thank you very much. Coffee break.
Hello, letter people! This is Guido van Rossum. I'm the brother of the illustrious Just van Rossum and the creator of Python, a programming language named after an old comedy show. It may just be a coincidence due to family ties that you are writing font tools in Python rather than in Perl, but I think you would agree it's a happy coincidence. I'm not sure what else to say except that I wish you a great conference or hope you had a great one, depending on when Eric gets this video. Oh, and may all your fonts be beautiful, and may all your programs be Pythonic. Take care! Hello, letter people. This is Guido van Rossum. I'm the brother of the illustrious Just van Rossum and the creator of Python, a programming language named after an old comedy show. It may just be a coincidence due to family ties that you are writing font tools in Python rather than in Perl, but I think you would agree it's a happy coincidence. I'm not sure what else to say except that I wish you a great conference or hope you had a great one, depending on when Eric gets this video. Oh, and may all your fonts be beautiful and may all your programs be Pythonic. Take care.
And let's see. So everybody, I would like you to welcome Frederik Berlaan.
Okay, that makes me even more nervous somehow. So thank you. Oh, thank you, Eric. Thank you, Eric, Paul, for inviting me again. It's like homecoming a little bit. I was asked to do a lecture here. I thought, I don't have anything new to show. Working on RoboFont takes a hell lot of time. Answering emails taking a lot of time. People complain, but they complain nicely, so that's a good thing. So thank you very much for complaining nicely. But on the side note, I'm actually also making more tools, and maybe I'm just going to show some stuff today. But first I want to tell a little bit of a status update for RoboFont. So after releasing it from 2011, like 4 years. And actually it's like so far so good. It's still holding up. A lot of people are using it. A lot of people are here and using it, so thank you very much. In that time there were like 10 public releases, which is kind of a lot if you compare to others somehow. But there were also 111 beta releases, and I counted it out. That's like each one in 9 days. And that's kind of a lot for doing like beta testers. There are like 71. I think this is also a conference full of beta testers. So hi everyone. And also want to thank every beta tester for their precious comments, their critiques, their being very precise and being some harsh sometimes. But that's what makes the things actually better. From a code point of view, RoboFont without all the packages, the building blocks, the shoulders where I stand on, is like almost 3 million characters. That's roughly 256 files. That's a book about 600 pages, which is not bad in 4 years' time if you have to write a book. But if you compare it to how many trees that you need, it's not that much. So it's going to be, yeah, a lot of work. But what actually makes me really, really happy and is one, there is an extension mechanic. So hi, Jack, I don't know how you look like. So hi. Thank you for writing it. It's, I think, the best extension ever for RoboFont. If you don't know it, you're an idiot. Sorry. But there are like more than 60 extensions available on Mechanic, which is open source. And these extensions come from different kind of people, from single type designers making really cool stuff, to big foundries releasing stuff on Mechanic, to big companies. And it's kind of a mixture of all these kind of tools that people are actually using and making the stuff and making it work for themselves and are able to share it with the rest of the world and the community. This is also a very good motivation to keep on working and to keep on very strict to the ideas which are in RoboFont somehow. That it's like extendable, that it's a powerful tool that people can make their own workflow somehow. And I guess I'm writing a lot of custom extensions, but I think there are more custom extension inside companies, in foundries, of people writing stuff for their own but not releasing it, which is fine. And it also makes me really happy. So far, sorry Tal, no UFO 3. It's been 3 years, I know, but sincerely sorry. But again, there is like 1.7 will be released very soon. I hope maybe during the conferences or the week after it will be released. No big changes on bug fixes, but for people on a MacBook Pro Retina screen, it will run 4 times faster. Yeah. No, not going to go in details. The future, how does it look like? I don't know. I wish I had like a police box here standing and then jump in and then fly over, but that's not going to happen. So the first thing is on the list is support for UFO 3. But it means that also a lot of things has to be rethought and rethinked and rewrote to get that done. And another thing which is kind of really important, because I see that a lot of people are making extension, making it bigger than it actually is, but at the end you get like a list of 60 extensions in the extension menu, which is not workable anymore. So there should be a new way of installing, activating extension. I had a good email conversation with Jack about it. He's posing very good ideas how to maybe then bind it to a UFO, to a font, or to a project, so specific kind of extensions can be activated while you open up one specific project that you're working on. So it's more in this direction in how to structure, how to manage actually your extension and how it can behave so it still looks like a very workable kind of environment where you work in. So far so good for rounding UFO. It's a kind of a tiny kind of application, which is kind of a fun thing. But there is a UFO 3 version of it, which I can show very briefly. So I have a wonderful typeface. Whoops, it's too big. So the thing is, it's just narrowed down to one typing line, so you can, hey, hi, Robothon. The thing is that you can click on it, and then you have all the sliders, you can have global, local values, and then but the biggest change in this version is that all these parameters are stored inside the font lib or in the glyph lib, so you can actually share this kind of files with other kind of people instead of just copying the values from the checkboxes, which is kind of stupid. Simple application, so that was an easy one to convert to UFO 3, so don't save. So far so good for UFO stretch. UFO 3 is also coming. I'm working on that, but there is no demo, so sorry. Building blocks. Pedro mentioned already like a lot of building blocks in his talk. It's really standing on shoulders of giants to be able to work and to write RoboFont and these other kind of tools. But sometimes while you're writing RoboFont, you're also thinking, hey, maybe this is also a building block. So I open sourced some of the parts from RoboFont, which I just extracted and built on top and just made them available as a building block. So one of them is building operations. This is actually the remove overlap that initially started as a project together with Tal. It was first in DEF CON, not the right place, so we extracted it from DEF CON, so it got its own kind of package. And it's kind of a nice way. It started because 4 years ago, the checkout lines of the FDK that was being used for remove overlap in RoboFont was not really good enough. That changed a lot over the years, so that's a very good thing. But still, things are missing, and you can only like check outlines, do a remove overlaps, but there are other kind of path operations that you can do, like an XOR, a difference, a union or an intersection, which is kind of nice that it's now actually available as a package. So this is also open source, so people can just do a non-lab remove overlap or do crazy stuff by intersection and cutting out of paths out of each other. Simple sample code. Thanks, David, for input. So the thing is that you just import a Boolean glyph, which is kind of the same like a math glyph or math font, but it just knows how to extract and to work with paths and to union them, difference them. This can be actually, whoa, sorry. Small demo. I have a green RoboFont, which is funky. It is changing every time I start up RoboFont because it makes me happy. Boolean operations. Boolean operations. Oh, I have to open this in Drawbot. Drawbot is also, we'll talk about later, Drawbot. Also a nice RoboFont extension, and a nice one. I don't know if anybody is using this, but you can actually enable it, that you can open directly Python files in Drawbot. So if I now just drag in there, it's there. So what this script is doing, it's getting the current font, I'm getting the A glyph, I'm getting the B glyph, and the first thing I'm going to do is a union, and then I'm going to stroke it and draw the glyph. So the first you have a union, which is kind of logical, right? And the difference is kind of different if you reverse the order, because the difference, if you have like one part on top of each other, it just cuts out different kind of sections out of it. The intersection is where two parts overlap, and the XOR is actually the other way around. And this is actually just a pathfinder, but then for RoboFont or for any kind of application, because it's open sourced, so you can just do whatever you like. So this is kind of understandable code for everyone. It just this kind of operators are the same for sets as for other kind of tools, which are also doing a union on list or something on different kind of objects somehow. So okay, bye bye. Back to the presentation. Another thing that I noticed, which is actually a building block, is the OpenType feature lecture. Maybe a short explanation what a lecture is. In RoboFont, every syntax, every code is actually highlighted with pigment. Pigment is a package to highlight syntax. Like, for example, then you have nicely colored code when you're writing Python code or XML or HTML. That's all available inside RoboFont. Pigment is not for me, that's an open source package. But I wrote the OpenType feature lecture, which is actually a kind of a script that is able to understand syntax and then put the nice colors on top of this. So this is working, you're all familiar with this, but it's kind of nice that other people are using, like Tal's very well documented OpenType cookbook is also using this for his website. So that's kind of nice that other people are interfering and using this kind of tools. Drawbot. Oh, that's kind of big. Okay. Drawbot. A year ago, I asked Just if it was possible to make a new Drawbot. So we sat together here in The Hague, had a nice drink, some coffee, some cigarettes, and we discussed how Drawbot could look like, and it's been completely rewritten. It's Drawbot 3. The icon is from Andy, also here. Where's Andy? Hi, Andy. Thanks for the icon. It's actually a really nice story. I was chatting with Andy, and he told me there was like a contest when he was here in the TypeMedia, to, and the contest was that you had to draw a new icon in Drobot for Drobot. And I think Just never used this. But then Andy was then telling me, hey, I still have this code. And actually this code was still working in the new Drobot. So that's kind of the very funky, freaky kind of logo, which is kind of a nice way. If you don't know Drobot, shame on you. It's the tool where I started to learn Python. My first calculator interpolator was written completely in Drobot, which was kind of weird, but it worked somehow. It's a nice tool for educating people to learn designers to code because you have a visual output. And in the new one, I just added like a lot of support for setting text. So we have now a text box. A text box has overflow. And you can do stuff with it. You can really design. I don't use InDesign anymore. I just make every kind of thing in Drobot, which is kind of a nice way, because it's faster for me somehow than moving a mouse. Nice things like open support for OpenType features. This is kind of limited because it's related to everything what Apple as an operating system is offering. But the weird thing is that the core text, which is a lower level library that Apple is using to display and set text, is actually much better than what you have in the UI in a text editor somehow. So you have more access to different kind of features, OpenType features, text support, hyphenations, which in a very weird way it knows the language that it's been set in. It's kind of a very kind of interesting kind of tool. Okay, building tools. They are like same kind of list that Petra was showing earlier. Building tools that a lot of different kind of people like Eric, Tal, me, Just are writing. They are like open there. You can use them. And actually, RoboFont is actually in the middle somewhere, or more to the left. You just have to connect the right dots together, and you have a kind of a very cool application, or a very kind of a cool extension, or a tool that just can do one small thing. It's in there somewhere. You just have to connect the dots together somehow. So again, Drobot. Drobot also works as a module, which is kind of nice because you just can do from Drobot import all. You don't have a UI, but you just have a piece of code, and then it's kind of working. Already showed it. There's also Drobot, the RoboFont extension, and actually you can do really, really cool stuff with it, because then suddenly, I've got to open up the demo font, extensions, Drobot, settings, enable. Oh no, I don't need this one. Sorry. Where is the external Drobot? Open this in RoboFont, and because now you can use all the powers the superpowers that Drobot has, but with all the superpowers that RoboFont has, with all the lower level building blocks, and then you can build on top of that. So in this example, I'm just going to import everything from Drobot. I'm kind of lazy, just import everything. I'm getting the current font, which is this one. I'm doing a test install. I'm initiating a new Drobot. And in there, I'm direct powers of Drobot. The A, have a nice A. I didn't draw this. This is Bram de Does. And the nice thing is that you have, for example, whoa, okay. All right. Sometimes because no, because okay. I can then just trade off. It's nice to trace different kind of tools. So this is also available just in case if someone wants to trace, maybe someone wants to optimize the path which is then getting back into RoboFont somehow. But the tracing is done by PostTrace, which is an open source library. Slanter, this is something that I actually use quite a lot. I'm just going to also demo this quickly. So, Slanter. Slanter just slants map the components in that glyph. There is an option already to have an add top, which is actually using the anchor and the anchor name and the underscore anchor name of the anchor, which is and then the last option already in RoboFont is to add a Unicode with the bar, which is kind of a nice way to build up glyphs, but I think you can do like a lot more with it. So I put a lot in it. I'm just going to describing let's start out like an A graph is equal to an A plus a graph. So there we have it. Maybe I just have to okay, remove this one. Remove this one, sorry. Graph, remove this one. Okay, if you just run as the position kind of level, you can position of the and it will somehow. Therefore, 3 guides are supported. So in RoboFont there are already guides, so this kind of a guide kind of thing. So we can also use guides to make to set the position of accents. There are different kind of guides. You have global guides, local guides, and glyph construction looks in a different kind of order. So first it will look for global guides. If there are no global guides with that name, center and top, then it will use the local guide. If there's no local guide, it will look for anchors. And then it will look for the anchor with the underscore notation. And if all of these are calculated, also which is has no anchor point or local guide which is referring to, so it will calculate it from the top bounding. Kind of a nice the whole thing later on. A problem now, the A and the U have a different kind of top because the A has overshoot. So in this case, it's kind of a graph has a width left margin because that comes from the component. It has components in a and a graph and a Unicode value. Overlap and
Did we like, hello? Did you like the sandwiches? Did you try the mackerel sandwich? Mackerel was good. And the old cheese? And the pate with pickles and something? Oh man. We just have lunch and just skip the talks. The lunches and the cakes are made by the person who always makes them in every conference so far. The cake, the slices of cake. Yeah, that's at the first coffee break. There were cakes on the tables, and the people near the door know. You know, the people further. The next person is Tal Lemming, and he is going to talk about the UFO format. Tal.
Okay, so first off, thanks to Paul and Eric and the Academy for putting this on again. This is a great conference, and it's always amazing to see how much bigger it gets each time. And also very quickly, my wife, my mom, and my kids are probably watching this, so. And you're right, Timmy, this is boring. He's 3, and everything is boring, especially this. So I'm going to talk a little bit about the UFO today. So 3 years ago, I stood right here and introduced UFO 3. And following our rules, I should be introducing UFO 4, but not today. I do want to talk about it, though, because we have some things to decide and some things to discuss. But first, a little back history. This is going to be redundant. Everybody in here knows all this stuff, but it's going to be important when I talk about what we need to do with UFO 4. So, UFO 1, 2, and 3. So before the UFO, there were all these different editors, and each editor had its own file format. The different file formats reflected what the editors themselves could do. There was a core that Fontographer established, how we manipulate points, how we manipulate kerning. Most of that stuff came from the very first version of Fontographer. And that sort of laid the foundation for what most of the editors back then and still today do. But some editors support multiple masters, some don't. Some support other things that others don't. So there's not a one-to-one overlap between their file formats. With UFO 1, we more or less targeted right in the middle of that, and we covered most of the important stuff, outlines and components and kerning. With UFO 2, we expanded it, and we made it support more font info for enough stuff to generate OpenType files and that kind of thing. In each of these, we never went outside the bounds of what the existing editors could do. With UFO 3, we did something a little different. We looked at not where we were and where we had been, but where we were going. And RoboFont and Glyphs were out, and they had support for layers. And Fontographer had established a model of having a foreground and a background, which we'd all gotten used to, but I don't know about you, but I don't remember what it was like before I could draw without having arbitrary layers. You know, it seems like every day I make a new layer with a random name, and that's become an essential part of my workflow. And so we thought, okay, well, we need to support this. So we built that into UFO 3, even though some applications didn't support that yet. We also added some things that nothing supported, specifically a thing called object identifiers. They're persistent. We looked at what tools were starting to do. And 3 years ago, there weren't as many extensions and separate tools as there are now, but there were still a lot. And we recognized that we were sort of hitting the technological limit of what we could do in those. For example, you know, some tools will offer outline editing, or some extensions will, and they do very specific things. And as soon as you close that extension and start it back up, it doesn't remember any of that. It doesn't remember what you did before, or it has to guess. So one of the things that we built into UFO 3 was the ability to add a little tag to a point or a contour or a component that could then be stored and remembered, and those things are supposed to be persistent. Nothing supported those. RoboFont has some experimental support for this, but that's the kind of thing that's going to be difficult for developers to implement, and we knew that. We just think it's an important thing going forward. But when we're developing these things, this is the balance that we have to strike. We have to think about what designers need. Because I'm a designer, I want my file format to do everything, including things that I haven't thought of, including things that you haven't thought of. That's, as designers, we don't want any limitations. But the thing is, even though there are 180 people here, we are a small group. We don't have millions of type designers, even though there are, I don't know if this is historically accurate, but I think it is. I think there are more type designers now than there ever have been in history, but we're still a tiny group. There are no multinational corporations with 1,000 developers making font editors. So we have to be realistic. And I say that as a developer because I write tools too. My own tools don't support UFO 3 yet because it's a complex thing to implement and it's going to take some time. But this is what we have to think about. Ideally, when we publish a version of the UFO specification, these things overlap perfectly and everybody's happy. With UFO 3, it was more like this. So there were some things that are not going to be easy for developers to implement. We knew that, and it's just going to take some time. My own tools, I don't know, they'll support UFO 3 soon. Sorry. I have this internal conflict about when they should support it. All that said, the UFO is now more in every way than we ever imagined. When the UFO started, it didn't even have the name. Eric and Youst were working on a typeface together, and they weren't in the same office. They had a server between them, and they needed to work on the same font file at the same time, and nothing did that. So they invented a format that would allow them to swap glyphs back and forth. Shortly thereafter, I wanted to make a kerning editor because kerning is the worst thing in the history of mankind, and I wanted to make it less so. And I needed a file format, so I just made one up. And then it just became this joke. Okay, we have our own file format now. And then UFO 2 came along, and then UFO 3, and suddenly this has become a real thing. Eric and Youst and I don't think we ever imagined that this file would be a central part of our workflow, but it has become that, and that's great, and we're very proud of that. But we have to start thinking about things going forward. So, now what? So we've got most of the low-hanging fruit. We can support points, we can support contours, we can support most of the basic stuff that we do. So UFO 4, what are we going to put into it since we already support just about everything that we need? New binary formats, there aren't really any. I stood here 3 years ago and said that we would have layered web fonts soon. I'm going to stand here right now and say we're going to have layered web fonts soon. Probably 3 years from now, I will stand here and say that we will have layered web fonts soon. There are proposals for specifications, but as Eric and I have learned, a proposal at the W3C does not mean that it gets approved. So they're almost in exactly the same place that they were 3 years ago. We can't add support for anything to the UFO until it's official, and none of those layered font formats are official yet. There's something called WAF 2. Eric and I are not involved in it, so you know about as much as we do. But as far as I know, it's mostly about compression. So there won't be any changes needed for the UFO to support that. We do have some possible ideas about what needs to go into UFO 4. Hint. You can probably hear the resignation in my voice. So we've been talking about how to store hints in the UFO since before the UFO existed. That's not an exaggeration. I remember sitting 12 years ago and writing an email saying, I don't know how we're going to do this. And we've been more or less stuck there since then. Hints are a deeply complex thing, but they are not going anywhere anytime soon. I am pretty sure that after the sun burns out, the only thing left on Earth will be hints. They will have taken over, and they will still be in the same format they were in 1986. So, we've got to support them, unfortunately. The problem breaks down to this. We'll start breaking the problems down with this. So there's PostScript and there's TrueType. We had this grand dream that somehow these would be unified into one thing, which we were able to do with outline data inside the UFO. You don't have to have two completely different specifications for the UFO just so you can have TrueType or PostScript. They're the same. We thought we could do that with hints. It's not going to work. After thinking about it for 12 years, I've decided that we are going to have two different blobs of hint data, which sucks because we don't like doing that in the UFO, but these things are they're completely different, and there's not going to be a way to resolve that. PostScript. PostScript isn't that bad, actually. The format's pretty simple, and Adobe has proposed a way to store them in the UFO. I've got some ideas for improving this, so this one's going to be pretty easy to sort out. PostScript, not a big deal. TrueType, on the other hand, is awful. Who in here likes the TrueType hinting format? Nobody. I don't think it likes itself. So, this is what actually gets stored in the TrueType file. You can call it binary, you can call it assembly, you can call it instructions, you can call it the program. Everybody calls it something different. I'm probably going to call it all those things. It's just this blob of data. This is not human editable. I mean, maybe somebody can, but I don't think that this is the kind of thing that any of us want to write by hand. But this is what goes into the TrueType file. So if we look at the stack of how this stuff is built, we have this. That stuff at the bottom is kind of terrible to try to edit. You don't want to edit your hints in a text editor. I mean, I know we don't want to edit hints in general, but you really don't want to do it in a text editor. So applications have built their own abstractions on top of that. I'm partial to FontLab's Align, Link, and Interpolate model. I think it's a really nice, simple, but powerful abstraction. And it compiles down into this. So we can click and drag and move things around and have it, work. Problem is, every editor has its own version of that. Sometimes they share the same names for commands, but they don't compile down to assembly the same way. So that kind of sucks when you're trying to standardize things. Back when we were drafting UFO 3, Eric and I had this idea for a thing called links, which were not links in the FontLab hinting model terminology, but they were just a way to say the points in this group are this kind of thing, and you could attach an arbitrary definition to it. You could say this is actually just a group, and you can move things around in an editor as a group, or you could say this defines a stem. Links were an awesome idea to me and Eric, and everyone else told us they were stupid. So screw you. They were a great idea, and they're coming back in UFO 5. So we thought about this, and apart from everybody saying that they were a bad idea and they wouldn't be useful for anything, the problem is, while we could define these things and say these could be used for hinting, the underlying problem was still there. There wasn't a standardized set of commands that would compile down to assembly. They all do it differently. As designers, if we hint something in FontLab, and then we switch to RoboFont and we generate our TrueType file there, we want the hinting instructions to be the same as what we previewed in FontLab. Because every tool has its own abstraction, it also has its own translation from that abstraction to assembly. So that's not a standard. We could make a standard that lived on top, but you would still get different results, which is not good in any way. So then we thought, okay, well, what if we make our own translation from our own format to assembly, and then we remembered that we don't want to do that, because that would be horrible and a tremendous amount of work. Could be done, but probably not. We don't have the expertise for that, and it's questionable whether it would actually work. So we're back to this. Everybody has their own thing. Next thing I thought was, okay, maybe someone will say, you know what, I'll publish my specification. I'll say, these are my abstractions, and this is how I translate it to assembly. Just from my experience, I had the assumption that if someone were to do that, everyone else would follow. So all the different editors would then suddenly support that. This hasn't happened. It's understandable. The work for creating an abstraction itself is tremendous. And then creating a translation to assembly is an enormous amount of work too. So it's understandable that this stuff is not, the different editors haven't published this. It's a point of differentiation for the different products. So the one constant throughout this has been this assembly. So this is kind of what I'm thinking now. This is what we'll store. That way, if we edit something in FontLab, then if you open it up in RoboFont and generate the hinting instructions will still be there. You won't be able to edit them the same way you would in FontLab or whatever, but at least there will be something there. It's not ideal, but it's probably the best we're going to get. TTX has a text format for referencing these, so we can piggyback on that and use that for it. So in practice, let's say you have this H. There's one complication I'll make a third. Let's say you have this H, and you open it up in FontLab, and you define your hinting data, and you save it. So now your UFO contains your H and your hinting data. What if you then open that up in, let's say, glyphs? And you decide, that crossbar is too heavy, and you change it. The way TrueType code works, that is now invalid. It's all wrong. Logically, we can't expect editors to know what they need to destroy if something is changed that then makes everything out of date. It sounds possible, but logically in standards, it's not something you can define. So there's a bit of a problem. Glyphs then saves, now the UFO has this in it. So we all know this. We've all seen the rasterization problems that can happen if hinting data is no longer valid. We've all seen that computers can crash. We've all seen that kernel panics can happen because of bad data. As the editor of a spec, that scares the hell out of me. And you know, if you look in the U.S. government has a database of known software vulnerabilities, and if you search it for font, you get a surprising number, and a frightening number of those are hinting related. So the fact that this data is now out of date because we made a simple modification is scary. Because if you now open this up in, say, RoboFont, and you go to generate your TrueType file, RoboFont does not know that that data is invalid. So that's why my voice is trembling. because this is a very difficult problem to solve. I miss the days when all we were trying to do was define move to and curve to. So how are we going to fix this? Not only are we going to store this, we're going to have to store basically a synopsis of what the glyph looked like when the data was made. We can do that with a cryptographic hash, like an MD5 or something like that. But those are all or nothing things. For TrueType, certainly if you remove a point, this is all completely invalid. PostScript hints are much more flexible. If you just change the crossbar on the H in PostScript, that hinting data might still be okay. So I don't want to use something like a cryptographic hash for representing the state of the glyph. We have to come up with something that can be dissected so that if a tool is smart, it can go through and say, okay, this is what changed, so that it doesn't destroy everything. This is something we can reuse for other things, like this will be used for PostScript hinting and TrueType hinting, and the same fingerprinting mechanism could be used for other things as well. But this is something we have to invent. And we've got to do some research to find out if any work has been done on this kind of thing that we can learn from. So, yeah, hints. Thank you, Microsoft. My boys say, why are you grumpy, Daddy? And I say, Microsoft. That's mean, but not completely true, and also not completely false. So some smaller things. Glyph names. We've all been making fonts in here for a long time, so we know that there are things that are dumb, that we've forgotten that are dumb. I teach an introduction to type design class. Glyph names just boggle students' minds. It just makes them want to cry. We all understand this. You know, but it's confusing. Think about it. We can call an A, right? Okay, that makes perfect sense. We can call a 1, no, we can't call a 1 a 1. We have to spell that one out. Well, okay, logically that makes sense because you can't spell out A, but you have to spell out 1. So I can't use numbers in glyph, oh no, you can use numbers in glyph names, but not at the beginning. Okay, so this quote thing, that's a quote double left. No, it's quote double left. And everything is relying on the Adobe glyph list for finding Unicodes. So then my students are like, why doesn't my quote show up? I'm like, well, what did you call it? I called it quote left. Well, okay, well, that's not the name. It's quote double left. Like, okay, so I put the space. No, don't put a space in there. They don't get it, and it's understandable. It's crazy. I understand technically why we have to do this, but it's 2015. We shouldn't be doing this anymore. But I kind of have an idea. This is a half-baked idea. I think we could store what I call a design name, and editors could use this so that my students stop emailing me at 2 o'clock in the morning and expect me to be awake to tell them to eliminate the vowels in their glyph names so that it will get the correct Unicode value. So, private lib. This is something Adam Twardock suggested, and I think it's a good idea. As Peter mentioned and Frederick mentioned, we're all storing, all these tools are starting to store data in the lib for their own tools. And that's going to become even bigger with UFO 3, with those point identifiers that I mentioned, because their capabilities are going to expand pretty dramatically. But Adam pointed out, a lot of tools are putting this data in, and other tools are starting to modify that data, and then there could be errors introduced, which would be bad. So say you edit something with tool A, and then tool B modifies that, and then you open it up with tool A, and tool A is not doing any sort of validation on its original data, and suddenly everything implodes, and everybody gets worried. So I think we could solve this pretty simply by just adding a little private prefix to the location of where the data is stored And that would just be a neighborly, please don't screw this up. So that's pretty simple. And actually, none of these need UFO 4. These are all things that we can put into UFO going back to UFO 1 because of the way the UFO is structured. So I'm going to propose some of these on our mailing list, and we have space in the specification for defining these small little things and the locations that they're in. That doesn't mean that tools will automatically support them. It just means that the data won't be lost if a tool does support it or doesn't support it. So, but one thing that will require UFO 4, file structure. Okay, this is the big one. I might have to sit down for this one. So what's wrong? Nothing, but everything. But nothing and some things. Using UFOs with Dropbox is slow. Yes, and I don't mean Dropbox specifically here, I mean Dropbox, as in a remote server that you don't control yourself. It's understandable UFOs contain thousands of tiny little files. Dropbox is built for people who have a relatively small number of very large photos. It's not tuned for dealing with thousands of 1K files. So it's slow, and it can cause offices to come to a screeching halt. Sending a UFO by email confuses my students a lot, repeatedly. No matter how many times I tell them not to drag the UFO into mail and hit send, I will not get it at 2 o'clock in the morning, so I can't fix it unless they zip it first. And I have to tell them that 3 times. Hi, students, I'm sorry. It's understandable. I mean, it looks like a file, which brings me to this. Only OS X knows about package file structures. If you look at a UFO on Windows, it looks like a folder, because it is a folder. Pulling a large font from a source code repository can take a very long time. Fonts are getting bigger. The languages that we support are increasing. Now there are layered fonts, and someday there will be a specification that supports them. And these things are just getting bigger and bigger and bigger. And people are using source code repositories, but pulling a large font out of Git or diffing a large font with Git can take a tremendous amount of time. These are all things that people have contacted me about with very serious questions about how we're going to solve them. All of the problems go back to this. When we made the first version of the UFO, we used what's called a package file structure. This is a very neat little structure that OS X supports. It goes back to the next days, I think. Basically, you can define a directory structure, and OS X will recognize that as a file. Apple uses it for quite a few things themselves. And it was a good idea at the time, but times change. It's not necessarily a bad idea now, it's just things are different. Dropbox didn't exist then. We didn't know that this file was going to be the center of a lot of people's lives. So we need to solve it. This is going to take some time and is going to require community effort. So this is why I did that redundant history. We're always trying to strike this balance, but this time we need to do this. We need to figure out what developers can support really easily, because UFO 3 was a big change, and we knew that going in. We don't want to throw another huge change. We want to try to find a way to solve these problems while requiring as few code changes for tool developers as possible. We want as much of that code to be reused so that supporting this new structure is relatively easy. So we can establish some criteria for how we're going to evaluate the different candidates for this. The UFO is human editable, which Those of you who used to work in the days when we had binary files and had them go corrupt and you lost a week of work, you know how important this is. If one of those files went corrupt, it was just gone. There was no way to fix it. I have UFOs go corrupt all the time. Software is going to have bugs. There's no such thing as bug-free software. The nice thing about the UFO is when it does happen, we can just open that UFO up in a text editor and fix it. 100% of the times, or 100% of the time that a UFO has gone corrupt on me, I've been able to fix it. There's never been a time that I couldn't fix it. So that's important to maintain. Extensible, we need to think about the future. We don't know what is coming next. The UFO has been really good at restructure, or not restructuring, but being able to support new file formats and new data types. So we need to maintain that. Binary files, for example, are not good at that. OpenType is kind of stuck where it is because there's not space inside of the definitions for adding new things. We don't want that to happen with the UFO. Ideally, it would be a single file so that my students stop emailing me directories. I don't know if I've emphasized enough how much of a pain that is. Easy for developers to implement, and we need to improve version control compatibility so that it doesn't take 30 minutes or however long to pull 40,000 glyph font from a repository. So I've been thinking about a couple of different ideas. One is a zip. And I actually tried this right after we made UFO 1. And amusingly, FontLab has the same idea, and they use the same file extension I did, which was UFOZ. So zips. We all know zips. We all love zips. Every operating supports them, or every operating system supports them. They're relatively easy to make. You could take a UFO in the Finder right now and zip it, and you would have essentially what I'm proposing. As designers and computer users, we like to think of zips as a box, and we can just drop things into them. So for the UFO, we could take our existing directory structure and just drop it right into a zip, and that would work. We could pull that back out. Oops, oh, wrong way. I hit the left arrow because the next one is going to be a left arrow. That was, see? So we could pull it right out. Zips maintain a directory structure, so everything would more or less stay exactly the same. Zips are kind of cool in that you can also pull out a specific bit of data. You don't have to unpack the whole thing at once. This is where zips stop being cool. So say you open up your UFO and you make changes to the A. You remove overlap on it. The way the UFO is structured now, you don't have to write the entire file each time. You can't just put this back in the zip. Zips are actually a stream of data. And if you just pull out one little bit and you modify it, you can't just slide it back in. Theoretically, you can. And I've been looking at different programming languages to see what they support. Python, for example, does not support this. Its zip file module doesn't support more than basic operations on zips. Ruby's zip implementation does, sort of, but Ruby is hard to read, so I'm not quite sure if they're actually doing it or doing some sleight of hand to make it happen. The issue is, if you pull this data out and then you modify it and you change the size of it, you then have to make space for it. So everything below that A would have to slide down, and the A could be reinserted. Or if the A is smaller, you have to close up that space. It might be possible to leave holes in the zip, but it's just not that easy. When you think about the fact that there could be thousands of glyphs in a font that have changed, and now suddenly you've got to coordinate all these holes. From a developer standpoint, that's complex. And since we don't want people to have to write a ton of code to support this, we have to think about what is easily available. So the baseline of what is easily available is writing the zip from scratch every single time. From scratch. Which seems okay, but we need to test it. If we have a font with 60,000 glyphs, each with 2 layers, that's 120,000 files. How long is that going to take? Every Command S is going to have to do that. So, I don't know. Zip looks really good on some fronts, and this is complex. So we've got to test it. The other thing is, in a text editor, this is what a zip is going to look like. If a zip goes bad, it's not all that easy to fix it. In fact, this very presentation that you're looking at is in Keynote, and Apple's iWork documents use a zipped package structure just like I'm describing. I saved this file on Dropbox, went to open it on a different computer and got this. The file would not open. I had to dig through the crash logs on the computer to even get a remote idea of why the file wasn't opening. This was a tiny little presentation. Imagine if this was an entire UFO that you've been working on for a month. I was able to rescue it. I won't get into how. Let's just say tears were involved. And this was just a little presentation. So zips are not a silver bullet on all this stuff. Human editable, maybe. Extensible, yes. There is a limit on the number of files that can go into a zip. Not too long ago, the group that maintains the zip specification modified it and doubled the number. So it's a very large number. And I think that if the world gets to the point that zip can't hold or needs to hold more files than that, they will update it again. So yeah, we'll say it's extensible. Single file, yes. Easy for developers to implement, maybe. Depends on speed and a lot of other things. Better in version control, no. It's absolutely worse in version control in every way. I don't know how to edit that in Photoshop. I mean, sure, you could copy and paste it into a new file, save it, then convert it from base 64 back to binary, open it in Photoshop, make your changes, then convert it back to base 64, copy and paste it into here, and it would work. But that does not sound like a good workflow. So that's not ideal either. So single XML file, human editable for the most part. Extensible, yes. Single file, yes. Easy for developers to implement, maybe not. It's not going to be as easy as zip, but maybe easier in some ways. Improved version control compatibility, yeah, that would be better. Then there's a hybrid, which I'm not going to get into too much, but basically we would have two. There would be a package structure like we have now, except that we would flatten it out some so that it would work better in version control, so that there would be, I don't know, maybe groups of glyphs within the glyphs directory instead of one single file for every glyph, or a single XML file representing all glyphs in a particular layer. And then there would be a zipped version of that. And it would be up to users and tool developers to determine what their default is. I think this is probably what we're going to end up with. It's not perfect, but we've got a lot of competing things to solve. The work to go to happen on this list so everyone knows what's going on. The source code for the specification is on GitHub, and I've had people fix typos. I've had people fix some of my ugly CSS, and that's been really great. That's really helpful. This thing is a lot of work, and this isn't our job. This is something we just do because it needs to be done. So anything that anyone can do to help is greatly appreciated. And like I said, this thing is so much more than we ever thought it would be. It's not my format anymore. It's not Eric's. It's not You's format. It's all of ours. And I don't expect... Speaking of Eric, Eric is now going to give you a presentation about the one and only amazing Mutator math. So...
Presentation about Mutator math, which is my little mathematical model module that I made, and it might be useful for you. So my name is Eric. A question we get a lot is how to interpolate. So I'm going to do a little short class on interpolating. Ooh, interpolate, what does that mean? Well, interpolate between two things, two values maybe? Okay, so interpolating is finding a number between two other numbers, right? Oh, straightforward enough. Yes, you start with one number and then you add small amounts until you get to the other number. That's what interpolating is. Okay, presentation done. Well, maybe a little bit more. One number, we call maybe a fraction. Maybe you add fractions until you get to the other number. Or we'll just call the other number the difference with the other number. So you have one number, and then you add the difference, small bits of the difference with that other number until you get to the other one. There will be examples and pictures. Add it up. Rather than say a number, I'll just call it A, and the other number I'll just call B, and the difference with the other number would be B minus A. So far so good, right? We have one value called A, we have one value called B, and then we subtract one from the other. And this fraction thing, we'll just call it a factor. So, how to interpolate between two values is you start with one value and you add a factor of the difference with the second value. So this is a formula for interpolating. A plus factor times B minus A. Take note. Examples. So, here I drew a very fancy slider, or using high-resolution graphics that are really, really, really smished, aren't they? Look at that. Can I fix that? That looks horrible. See me ruin my presentation. There's this and there's that, and that's all. That's the same. That should be right. I have no idea how to fix this. And is it mirrored? Arrangement? Yeah, it's mirrored. It's almost square. Wow. All right. Well, it's all going to be math. There won't be any pretty letters to look at. So, although I'm a little bit disappointed, and you know, I'm. The ASCII stuff looks good. Yes, I know, but I'm still disappointed that somehow this is happening. But this is source code pro condensed. A secret project of Adobe. Now you can still read it, right? I'm sorry. There's so many things that can go wrong. So, suppose we start with number 0 on one end. We start with the number 100 on the other end. These are numbers that are easy to grasp. This is a formula we just made up: A plus F times B minus A. And we say, now, A is 0. We'll fill that in. And we say, my factor is 0.3. And the difference of B minus A is 100 minus 0. You know how much 0.3 times 300 is? Yeah. So, and no, these things move. That's a nice thing about making this math, so that you put these values in, and then you can calculate. So these look a bit like percentages. So you say it's 0.30 something, and then you get 30. These values are relatively easy to understand, so the formula works. It also works with other numbers. You can put other numbers in. So rather than say 0 for A, I put in 200. And for B, I put in 500. And I put in my little math, and I make it work, and it also works. So the formula is really easy. The numbers are understandable, if not a little bit condensed, but it works. So suppose I apply this formula to two series of numbers. There's one going from 100 to 1,000, and the other one going from 100 to 500. And you know what? This could be a coordinate. This could be an x and a y value. So you set up these things, you apply the formula twice, you have your factor, and you do your math, and then you get numbers that are in between. These little graphs are made in Drawbot. The little animation is made in Drawbot, so the little red dot, it actually works. So these are the coordinates that come out. Suppose you have 3 values rather than 2. One of them I call red, the other one green and blue. On the left I have pink, on the other side I have blue, and you run this. And then the color interpolates. So anything that responds to numbers, anything that's made out of numbers can be made to interpolate. You just have to feed every number into its own little formula, and then it will do its thing. So interpolating colors, this is how it works. So that's basic interpolation. Of course, we can make it a little bit more complicated. This is the slider that we have, and you do the same for the other edge at the bottom. So you got this one and that one and that one with the same factor, and then with those results, you can feed those again into the same formula and say, well, now we get to this one. So just by making the problem into a series of interpolations that all go down into single numbers, then it all becomes understandable, and you can actually do it. So we now have 2 factors. There's one factor that sort of goes in this way, and there's another factor that sort of goes in that way. So by controlling these factors, see one factor is going this way, one factor is going that way, by combinations of these factors, I can now address every point on this little rectangle that I drew. Width is 0, weight is 0. At the bottom left, width is 1, weight is 0. So you can see that width has increased from 0 to 1, but weight is not. They're still on the same side. So there are 2 factors. One factor changes, the other factor doesn't. I go to the bottom right. We're still at the same size, the same place for width, so width remains 1, but weight is now increased to 1 as well. So it's a different coordinate, a different location. And to finish it up with 0, weight is 1. No questions about this, right? All right. These locations, it's nice to talk about width and weight in, between zeros and ones, because the zeros and ones look like the factor that we were calculating with in the beginning, but really the coordinate system is completely arbitrary. You can say, well, weight is 1,000 and width is 1,000, or width is 1 and weight is 1,000. Actually, there's a little typo there at the bottom. I can skip over it. So factors can be other things you calculate with. The values in locations are a little bit more abstract. They can have numbers that are meaningful. So, for instance, the stem weight or the weight of the weight value in a font. Those kinds of things have a little bit more meaning than the factors. Design spaces can have many different shapes. Ooh. So we've seen one dimension with 2 masters. That's nice because it happens to be exactly one interpolation formula, but we can have one dimension with 3 masters. Right? We say the width is 0 at the left, and then the width is 500 in the middle, and width is 1,000. You would have to do some calculating to get the factors right, because basically between the left one and the middle one you're doing one interpolation, and between the middle one and the right one you're doing another. So you kind of have to jump your factors around. But this is basic computer science. So it takes me a year and you make it work. You can have one dimension of 4 masters, or you can have two dimensions with 3 masters rather than 4. Oh wait, but what happens? There's undefined stuff. What happens at the corner at the bottom right? Extrapolation is what happens. And funny things happen, but you can just insert a master. Say, well, okay, 2 dimensions, 4 masters, 6 6 masters in 2 dimensions. I find this really useful. So you have 3 weight masters and 2 width masters. I thought this was crazy, and then somebody made it work. 2 dimensions with 9 masters. Okay. 3 dimensions with 4 masters. Anybody? Or 5, or 8. I love this cube in ASCII. 3 dimensions, 8 masters. So some of these we recognize from multiple master days, 2, 4, 8, 16. But I hope you notice that there's also all sorts of other stuff in there that might be useful that is not necessarily multiple master. 3 dimensions, 12 masters, had to make this once. Gets a little bit confusing, but it works. And then somebody made 5 dimensions with 32 masters. You know who you are. I did not know how to make a picture for this, but I imagine it sort of looks, it can look like some sort of a hypercube intersecting a 3-dimensional space and then being rendered in ASCII. I have no idea. It was cool. So, design spaces have many, many different shapes. Why? Because our ideas are constructed differently all over. Every time you choose to do something with interpolation, your project is going to be different than the next one, and it's going to be different from the previous one. The design spaces are determined by what you need to get done in your design, not by what the technology says that you only have 2 or 4 or 8. So do not let the tool or format determine the construction of your design, please. At least try to push it a little bit and resist a little bit. And think of all of the cool things we want those new interpolating web fonts to be able to do. We've seen some wonderful examples, and I'm looking forward to talking about this. I think it is maybe one of the most important things that web fonts should be able to do, to interpolate and to get a little bit bolder or wider or heavier or God knows what you're thinking of. But these fonts should be able to do this, and they're all parameters. They're all rendered live on fast displays, on high-resolution screens. Of course these things have to be active. Of course these typefaces have to respond and have to have the math and the dimensions to do this. So please, let's not go back to multiple master. So that's interpolation. Now, the rest, what is mutator math? Mutator math is plumbing. How to get stuff in and how to get stuff out. If I ever start a plumbing company, this is how I'm going to call it. So, how to get glyph geometry into the interpolation and how to get glyph geometry out. It would be nice to put 2 A's in and get an A out, right? How to put kerning in, because the kerning has to interpolate. How to put font info in. Plumbing. Let's have a look at the plumbing. In this case, the mutator math package is the plumbing. What is it? Written in Python. It's open source with generous support from Adobe, and I'm really pleased with that. Thank you. And it's available for absolutely nothing at GitHub Lederer Mutator Math. It has examples and documentation. But what is it? There's a little calculating thingy, which I call the mutator. I stole the name from the mutator application that Apple once made for their GX fonts. That I'm stuck between. Apple seems to be hell-bent on forgetting about GX, but it is also a really wonderful technology and a really wonderful format, so it's nice that it was there. And the mutator so wonderfully describes what it does, and I also don't want to take credit for it. So the name is a tribute to Apple's mutator, although mine also uses cubic as well as quadratic, and it does everything else, and it's a lot better. And in Python and documented in here. So there's also a location thingy, which is the location object, which I will show. And then there are some tools to process UFOs. The nice thing about the mutator and the location is that, I will show in a little demo, they don't know about fonts or glyphs. They just know about math. They put numbers in, and as far as they're concerned, they take numbers out. If you make an object that behaves like a number, it will work. So you can put in a color if you make the color behave like a number, or you can put in a rectangle if you make the rectangle with a different factor than the vertical. And this is the way I managed to define that. So this defines 2 coordinates on the weight axis in a single point, where the horizontal of the letter would then interpolate to 1, and the vertical of the letter would interpolate to 3. We'll you know what I mean. If you split the axes, you make the horizontal go a little bit different. You can tweak with the contrast. It's a lot of fun. Or now any dimension can have multiple values. This case, location only supports X and Y in anisotropic locations. I imagine it should be possible to go into any number of dimensions for this, but I've never had any questions. It could be anything. And I feed this to a function called buildMutator. I put that list in there, and I get a report whether it worked, which is the OK, and I get the mut, the mutator, which is an object that represents the mathematical, it's like the calculator of my, my interpolation work. I can now come up with a new location and say, well, what does it look like at snap 0.5 and 0.1? I call the make instance method on the mutator object, and I get a result. Because whatever I put in, I interpolate it, this comes out. So I can do 1, 2, 3, 16-dimensional interpolations without much of a problem. In Python code, slightly less simple pattern. You would have to import these objects, mutator math objects location, and get the build mutator. But still, this is a working example. Here I insert the value of 100 at a place called pop0, and I insert a value of 200 at pop1. And when I ask the mutator for the result at pop0, I get, luckily, the stuff I put in, the 100 I put in. If I ask for 0.5, which is right between the 100 and 200, I get 150. Nice. And if I put in 1, I get, of course, the other master, the other result. And if I put in 2, I get the extrapolation, which should be 300. I did not actually check these afterwards. I'm assuming buildMutator and mutator are doing their job. I can make this pattern a little bit more complicated. Rather than numbers with this, I can put in a whole glyph. Now with glyphs, it's a little bit more complicated because they, you know, there's more data associated than just a single number. There's coordinates, there's contours, there's a particular order, there are anchors, there are components, there's transformation matrices in the components. So if you want to calculate with a glyph, you need Tal's excellent font math module. I'll show the URL in a minute, which is basically you cast your glyph into a math glyph format as a math glyph object, which happens at this line. M1 becomes math glyph of glyph A, and then M2 becomes math glyph of glyph B from the font. I put that list in. I put those glyphs into Mutator. I ask for an instance, and I extract it. So I take the math glyph, and it becomes a regular glyph again, and that's the interpolation. It's a little bit more elaborate than the previous example, but still, you know, it's a lot less work than writing a novel. So it might be useful. These are the things from Type Supply. If you don't know them, take a look. DEFCON. A set of UFO-based objects for use in font editing. Which locations your instances have, the names your instances have, which folder you want to save them in, all of these things are stored in a file called a design space document. It contains everything you know to generate those instances. It's kind of like a superpolator file, but then with a different icon, and the information is structured a different way, and it doesn't have any superpolator application specific information. But you can export your design space document from superpolator 3, and then you will get a working document that you can feed into Mutator without any intervention from superpolator and calculate your instances. Or you can generate a new one with the design space document writer, which is the part of the Mutator math package. This is what a design space document looks like. It's XML. It says where your sources are, what the UFOs are called, which path they have relative to the design space document, what they're called, where you want to insert them in the design space, and where your instances are, what the instances are going to be. It's like all of the practical stuff. So how do you process your design space document? It's easy. You have the file path, you feed it to the reader, and you tell it to process, and then you have a folder of instances. This is the equivalent of hitting the generate button in Superpolator, but then this can be part of a build script where you do lots of complicated things around it. You do the same thing for subtraction, multiplication, and division. Of course, you divide by 0, you get a 0 division error. So all of that stuff is there. It's nice. I make another object in this case called a swatch. I want to draw it. I give it the same add, sub, div, mul, and rmul functions. So I now have a drawing object that has a size and a place on the field and a color, and it responds to math, and the color also responds to math. So I make a bunch of these swatch objects. I put them in a list, I give them locations. Blue that uses that is so much easier than having to fire up the app, click the buttons, and wait for it to happen. Because Mutator math is part of your build script. It will generate, and the build script will connect to other parts that generate your web fonts and do the proofing. All of that stuff is now invisible, and it's nice and fast. So thanks. We'll continue at 3 o'clock with the Bay Area UFO report by Miguel Sousa, sorry. Thank you. Hi. I'm sorry to distract you from your tweeting and maybe the occasional Facebook post, or maybe you're checking Facebook to make sure that your Instagram's arrived. But if you are properly caffeinated up, I want to maybe suggest keeping the doors at the back open. I opened up that one too, so maybe we can have a little bit more oxygen, because that would be good. The cake was good. Now, did you all get the cake? Yes, okay. We will now continue with the last two talks of today, beginning with Miguel Souza.
So, hi everyone. I would like to start by thanking the organizers for another awesome edition. This year the tickets sold so fast that by the time I woke up in the West Coast they were sold out. So my solution was to ask Paul and Eric if there was any slots for me to present. And luckily they said yes, so thanks guys. So my name is Miguel Souza. I've been at Adobe for almost 9 years. Currently my role is manager for Western type development. I'm also the designer of Vortis, an Adobe type concept font that was released yesterday. End of shameful plug. I'd like to start by explaining the title of this presentation, because I imagine that some of you are wondering what the heck is Bay Area. So these are Adobe's headquarters. This is where most of the type team works. The offices are located in San Jose. This big area here. And San Jose is located south of the San Francisco Bay, you see there. And as you can imagine, the area around the Bay is called the Bay Area. The Bay Area is home to dozens of tech companies, including Apple, HP, Google, Intel, Adobe, and so on. I think some of those companies are using UFO internally, but actually today I'm only going to talk about Adobe. Then you're probably wondering why not the title Adobe UFO Report? Well, because Bay Area UFO Report sounds a lot better. All right, so anyways, 3 years ago, our UFO story at Adobe was this. Number of projects in UFO format, 0. Number of UFO-enabled FTK tools, 0. Number of UFO-based apps in use, 3/4. So this last item is not 0 because we actually had licenses for a lot of the tools, Matrix Machine, Superpolator, and Prepolator, and we would play with them from time to time, but they were never, at that point, they were never used they were never major players in the workflow. So fast forward to today, the tally is UFO projects, 18, FTK tools, 11, and FTK and UFO-based apps in use, 7. Thank you. So I think it was a lot accomplished within these 3 days, and actually it was 3 years. So, and UFO is the format of choice for every new project. Okay, given that the format is more than a decade old, it surely took us a lot to get on the UFO bandwagon. But once we did, we actually started seeing the benefits of it. But had the plans not aligned in recent years, our transition to UFO would probably not happen as quickly as it did. So what got it started? Believe it or not, our first open source families, Source Sans and Source Code, were major catalysts. After publishing these projects on GitHub, we started wondering, how would we go about taking external contributions? At the time, the font sources were in VFB and Type 1 formats, and these don't really lend themselves to transparent version control. So VFB, as you know, is a binary format, so getting a new version, a new file, is like receiving a new black box. There's no easy way to see, to know what changes it has. Type 1, although it's text-based format, most of the file is encrypted, as you can see there. And this renders any diffs useless. So from one version to the other, it's like the whole chunk has changed. For a little bit, we experimented with decrypted versions of the Type 1 format. As you can see there, the hinting information and the char strings, so the defining each glyph, are in clear there. But this didn't last very long, because UFO was clearly the way to go. It's text-based, it's human-readable, it's diff-friendly, and it's a public format. So another thing that also made the transition to UFO more palatable was our move to Git as the version control solution. Prior to Git, we used Perforce, which is not a friendly environment when you have to wrangle thousands of files and deal with changes that include file deletion, addition, or renaming. Also, Git is open source, it's free, and its decentralized architecture allows for easy collaboration. By the way, if you're not very fond of using Git on the command line, there are several visual clients available. The one we prefer is this one, Source3, that is available for Mac and Windows. So when it comes time to collaborate with colleagues or with external designers, we share the changes via GitHub or Bitbucket rather than by email attachments. It's pretty easy once you get the hang of it. And even Robert Slingbach uses Git. So you can do it too. So what about the FTK tools? The work really didn't start until May 2013. So if you think about the last Robothon, 2012, March, it really took us a while for this to take off. And right now, that support is considered production ready. We have been using it for our own projects. And if you find any bugs, please let us know. All the appropriate tools can take UFO as input, including these three major ones, Make OTF, Checkout Lines, and AutoHint. And there's actually a new tool that was added, Checkout Lines UFO. It was developed for mainly two reasons. One is because the library at the core of Checkout Lines could not be open sourced. And the other reason was because that same library was so old, and the person who developed it, the engineers who developed it, they were not around, that was very difficult to modify. So Reed Roberts decided that it was time to make a new one and come Checkout Lines UFO. And Checkout Lines UFO is actually based on Frederick's Boolean operations library. It does a bit of post-processing to the outlines to make the resulting glyphs as compatible as possible to the original glyphs. And this is important because we needed to have because we need to generate TrueType fonts from a series of multiple master designs, and that whole workflow needs to maintain the compatibility of the outlines as much as possible, from the original design until it has been processed without the overlaps and so on. So one interesting feature about checkout lines and the AutoHint tools when they take as input a UFO file is that they create a layer called FDKO processed glyphs. So there you have the design layer with the overlaps and with no hidden information, and after it has been processed with checkout lines, there's no overlaps and the hints are added. So there were two reasons for the tools to work this way. One was because we didn't want to mess up with the outlines, with the design layer. So if you have overlaps, we'll just can stay overlaps, remain overlaps. And the other reason was to speed up the reprocessing of the fonts. So for example, if you run checkout lines UFO or auto hint on a font for the second time, it will only process the glyphs in the default layer that have changes since the last time. Okay. And by the way, when you run when you run MakeOTF on one font like this, MakeOTF will pick up the processed layer if there is one. If there's not one for a particular glyph, it will pick up the design layer. The way the tools keep track of the changes is through this file that was called the hash map. And this basically is a fingerprint of the outlines in the default layer for every glyph in the font. And so this way, sort of, I think it's made from the point coordinates and it's kind of the hash generated from that. So another thing that we were very looking forward to with the switch to UFO was the ability to define design spaces containing intermediate masters. So something like this. We had been using multiple master technology successfully for many years, but we were very aware of its limitations. So for example, every new access requires duplicating the number of masters, and sometimes some masters are just there not doing much, but they have to be sort of carried through. Moving to a UFO-based solution allows us to do this, and even we know that in some designs it's beneficial to have to be able to control that one sort of in the center or more or less around the regular where the design really is kind of the most used weight. So for a while we had Superpolator, and it got us most of the way there, but we really wanted the solution that could be scripted and something that we could include in the FDK. So luckily, we worked with Eric to open source Mutator Math, the engine behind Superpolator, and we couldn't be happier. Mutator Math has been available for less than a year, and it already enables us and other people to build new tools that would probably not exist otherwise. One of the ways we are using Mutator Math is to batch generate UFO instances from the command line. So the way we do it, and Eric explained this a little bit. First, we need a design space file, so something like this. This is a text file that specifies the UFO design space in XML format and defines the locations of the masters and the instances. This file can be written by hand, following the documentation available on the GitHub repository. But to be honest, the best way is to actually exporting it from Superpolator 3. That's how you do it. By the way, this generates as a single line. I don't know if you... I don't know. Could be. So once you have the design space file, you just need to use a new FDK tool called Make Instances UFO. to generate all the instances. This tool obviously uses Mutator math, and by default, the instances will be processed with checkout lines and auto hint. The script has options to change that. So it's very similar to one of the operations that comes by default with Mutator math. It just sort of adds another couple of operations on top of that. Okay, another important piece of the puzzle in our UFO transition was the font editor. And here I really need to give kudos to Frederick for his tool and for the top-notch support he provides. Experiencing how he dealt and still deals with bugs and feature requests really gave us even more confidence to move ahead with the switch to UFO. And in the 2+ years that we've been using it, we've really seen significant improvements, in particular how much faster it is when compared to earlier versions. Good job. So I must admit that the first time I tried the RoboFont, I was shocked by how bare bones the app was. Simple operations that I was so used to do constantly, like clear the mask layer, were nowhere to be found. Does this sound familiar to you guys? When asked about these apparent shortcomings, Frederick just said, well, this is by design, right? His plan was to provide the basic functionality and good extensibility hooks, which people could use for customizing the app as they pleased. And it has been really interesting to watch that philosophy starting to take off. Much of that success certainly comes from the many examples of scripts and extensions that Frederick made available, but also from the helping hand he provides when someone is trying to write new tools. Thank you again. As a result, a development community has grown around RoboFont, and everyone seems to be willing to freely share what they've made. And I don't know if you realized, but this collective group of people is able to accomplish a lot more and come up with so many different solutions than a single person would ever could or imagine by himself. And here's an example of it, a mechanic. At Adobe, we've also been, whoa, I can barely see the outline. At Adobe, that's an A, by the way. At Adobe, you've also been writing stuff for RoboFont, and we publicly released an extension last week. It's called Adjust Anchors, and it lets you preview all base plus glyph combinations and provides live feedback during the process of repositioning the anchors. And now I would like to do a demo for you. Can I do that? So it's pretty simple. So open a font. By the way, the extension is available through Mechanic. So it's right there. It's already installed. Oh, sorry. Thank you. Okay, let's see. I can just do this, right? Sorry about that. Whoa. All right, there. So the extension is already installed. Whoa, this is going to be difficult. It's like controlling a Mars spaceship from Earth. And now... Maybe. Nice. Is that working? Oh, yeah. Okay. Okay, let's see if it works better. All right, extensions, adjust anchors. So right now, this font has no, oh, it's so washed out. This window actually has a list over here and an area over there. Just imagine. So this font has no anchors. So whenever I select the glyph, there's nothing shows up. And just go about adding anchors. So add anchor, I'm going to call this above. I know that people like to call it top. I think above makes more sense. Add anchor above. By the way, the tool does not care about the name of the anchors. As long as you're consistent, it should just work. So now go to a mark, add anchor there. And now, as you probably know, this needs to have a trailing underscore, so above and above. And as soon as I add, you should start seeing something. There we go. And I'm going to add another one. Let's see here. Above. By the way, one of the things that the tool does not do and was not meant to do was to place the anchors. There's plenty of scripts out there to do that. And this was one of the reasons for developing it. It was to help us with our Latin extended families that require a lot of anchor placement, mark attachment, and so on, and also for our non-Latin fonts, Indian fonts, and so on, that rely a lot on the mark and mark-to-mark features. So if I'm in a marked glyph, I can see all the combinations from that. If I go to a base glyph, so if I go to the A, I should see all the combinations from that. And so this is part of it. So you can see in this window, you can see all the combinations, but it doesn't stop there. So if I zoom out and I select this, I can actually see and position it. By the way, on my screen is a lot smoother. And I can also preview it. So turn on the preview, and it will just work. And you can select more than one. You can select any of them. Okay? And so you'd go about it, and now I'm going to switch to the final font. Here we go. And by magic. So this is source sans, and you can see here there's a bunch of anchors defined, and I can just scroll through and really test. And depending on the glyph that I have selected, this window will respond as it should. And the same way, again, acute, combining there. And one thing that it might be interesting is, so let's see. Yeah, there you go. So it can do also, it can preview the mark to mark. So it's not just marks on top of base glyphs, but also marks on top of marks. And you can see here this chunk down here. And the way it's done is on the mark glyph, you do the underscore glyph name, and then on top of it, you treat this glyph as if it were a base glyph. Is this complicated? No? Okay, so this is what the extension does, so allows you to adjust it. And now, what can you do with this? So one of the things that you can do is generate the composite glyphs the same way as Frederick was explaining. So if you add glyphs, if you say acute equals A plus acute CMB at above uppercase, lowercase. And if I hit add, it should add the glyph down there, and it used the anchors to position it. And of course, you can have a series of recipes to generate whatever you want. That's one way of using this data. Another way is to actually output mark and mark-to-mark features. And how do you do that? You can do that from RoboFont. So if you go to the scripting window, I already have sort of pre-baked script ready here. It's too small. Is this better? So what this script does is it loads a module that we have made available on GitHub that is responsible for taking in all that anchor information and spitting it out as a mark and mark-to-mark features. So it loads that module. It takes in the font, the current font that is open. It figures out the path by seeing where the font is saved, and then it just goes about writing the outputting the mark feature. So if I press, so let's see, I don't need this. I have the font open. The font has anchors. The folder is here, so if I press play, I should get a mark feature, and there it is. So I would not imagine anyone writing this by hand, just like no one is supposed to write kerning features by hand. But this is it. And there's the module comes with several options. So right now it's only the default. It's kind of generating just the mark feature. But if you also want the mark-to-mark, you add there the generate mark-to-mark feature true. And when you run that, it now has another one. So this is the mark-to-mark feature that comes out from this font. Now you still have to sort of plug this into your features, but at least it's right here to include. And I think that's about it for this. So let's go back to here. All right. So, oh, wait a second. I need to get back this to, I need my notes. Sorry about that. All right. So this is, you can get this via Mechanic, you can get this via GitHub, it's there. I put this out last week, got bug report like less than an hour after, and I was able to fix it the next day, so I think I made 2 people happy, which is good. That is so washed out. The Python module I talked about, the right features mark, is here on our GitHub repository. Go get it. I think tomorrow Frank might talk about the other module that writes the current feature. So how am I doing on time? Good? 5 minutes? Okay. I need less. All right, so this should be old news now. And in sum, what I wanted to say is that a UFO-based workflow is now the default at Adobe. We plan to keep contributing to UFO's establishment, and you should keep an eye on our GitHub repository. That's it. Thank you.
Thank you. Now it is time for the last presentation today, which I think is also maybe one of the most exciting ones, but the Ornus brothers, Ornus, please. TrueType hinting in RoboFont. Can you hook this up? Do you need power?
Should be fine on the battery.
Good afternoon, everyone. I'm Jeremy Hornis, and this is my brother, Samuel, from France. I'm essentially a type designer, and Samuel is a computer science researcher. We're very happy to be here today, and we'll now introduce you to this hinting tool we are making for RoboFont. The point of hinting, first, is to improve the quality of rendering at low resolution on screen. TrueType hinting distorts the outlines by snapping the control point to the pixel grid in order to control the bitmap image. So far, one could do TrueType hinting directly on TTF with Microsoft VTT or with FontLab on VFB files. But there was nothing in the UFO world. Nevertheless, the UFO format became more and more common because it is open, human-readable, and well-documented. In addition, RoboFont enables us editing UFO directly, and it is a great tool that pushes its users to design their own tools. Instead of reinventing the wheel, we made the choice of reusing the data structure FontLab offers to define and describe visual TrueType hinting. It is widespread and relatively easy to use and to understand. I like technical challenges, and TTH was one of them. The advantages and motivations to make it is that we could add new functionalities and try to improve the user experience through a new graphic interface. We could also experiment with our own auto-hinting recipe and the hint copying utility. TTH is still in development, but we hope it will be of interest for the font industry. I will talk about a free tool that converts PostScript cubic fonts to quadratic, named Quadratic Converter. Then about the real-time visual interactive feedback in TTH. Then the few steps from the visual glyph program to the TrueType assembly itself. And finally, describe briefly what happens inside the UFO and inside the TTF. Samuel will then talk about auto-hinting and other things we are conceiving to make the hinter's life easier. But now let me show you TTH in a short video demo. With TTH, everything is accessible in a small tool panel that gives room to the glyph window where most of the hinting happens. The global settings or control values are accessible from there, and it is where you can define the alignment zones, the typical stems, and other font level settings. The pixel sizes, the working axis, and the visual commands are all in this small panel. You can see as you place the commands, the hinted outline in blue that's moving, the glyph program that's being written at the bottom, and the resulting assembly code on the left. There is also a waterfall of bitmaps at actual pixel sizes at the bottom of the glyph window. Here, I'm placing a middle delta horizontally at 17 pixels. With the selection tool, I can edit and access any of its attributes. Change the pixel range, for instance, from 17 to 24, and deactivate it for grayscale and subpixel. That's what I want here. Just keep it active for monochrome. So I can change the pixel size for the preview. The selection tool is a major feature of TTH. You can edit and access any command attribute with that, through that. You can also deactivate any command without removing it, so it's useful to check if it's useful or not. Of course, there is the preview panel where you can check spacing and word shape at different sizes, and you can always switch to a different rasterizer, monochrome, grayscale, or subpixel. So that's essentially how TTH works. Now, but before being able to use TTH, you will need a proper source. That means a UFO with quadratic outlines. And because we mostly design with cubic curves, we had to make a converter that prepares our files. Quadratic converter makes this task easy and customizable. You can define the precision of the conversion and adjust glyphs one by one to fix problems, if any. This tool is freely available through Mechanic and on GitHub. And now let's talk about the interactive feedback. That's, as we've seen on the video, as the user modifies something, like adding, editing, or deleting a command, the glyph program is updated. A new TrueType assembly code is generated, and a mini TTF is generated that contains only the visible glyphs. That font is then loaded in TrueType with the TrueType Python binding into TTH, and TrueType renders the glyphs as bitmap and extract the hinted outline that we can display in the glyph window. With the help of that output, the user can make modifications again and update the glyph program. The TTF generation is quite quick because it's a very small font with only a few glyphs. Now, the visual glyph program. It is made of a set of only 6 types of visual commands in total: align, single link, double link, interpolate, middle delta, and final delta. So a glyph program is a combination of those commands. Here you can see an example on the horizontal axis that is mainly single links and stems. And on the vertical axis, you can also notice align to zones and interpolating commands. But how do we get from the visual glyph program to the TrueType assembly code? We have to know whether a command must be before or after another, or if the order doesn't matter. So we have made a set of rules that compares commands by pairs, and that information is then fed into a topological sort algorithm that outputs an ordered list of visual commands. The point being to make the hinter's life easier so that he doesn't have to care about the order he places the commands. We then group the consecutive commands that share similar types in order to process them as batches. We use the TrueType reference points to translate the commands and their attributes into optimized TrueType assembly. We can see it here in this example. I hope so. Yeah. More precisely. So the assembly starts with the call to function 10 here that queries the rasterizer about its state. There are 2 states, either monochrome or grayscale subpixel. And we store this information into a storage area. That's because the option deactivate stem for grayscale and subpixel is enabled. The command number 1 here is a single horizontal link between 2 points, the left side bearing and the point of the outline, and it translates into this bit of assembly that takes the 2 points by their indexes and applies a move direct relative point instruction. The command number 3 here is a single horizontal link between 2 points, but it has a stem as attribute, the x80, And because the option deactivate stem for grayscale and subpixel is enabled, we read the storage area, and if we are in grayscale, we take the 2 points by their indexes and apply a move direct relative point. So it just behaves like before. If it's monochrome, however, we call the CVT number 9 here, that corresponds to our stem X80, and apply a move indirect relative point instruction. Those two middle deltas here, 9 and 10, have the same attributes, true for monochrome and false for grayscale. Because they have the same attributes, we can batch them and process them at once. So we read the storage area. If we are grayscale, we do nothing. And if we are in monochrome, we apply the deltas. So it's quite simple. Now what happens inside the UFO while you are hinting it? Beside what you see in the glyph window, TTH will write stuff in the lib.plist file. You might be already familiar with the com.type keys. They are added by RoboFont to store the app-specific information. With TTH, you will also find the com.samplon.tth key that keeps track of the rasterizer mode, the preview the rasterizer mode you are previewing the font with. And also, more important, if the stem must be deactivated when grayscale, there is also the com.fontlab.v2.tth key that stores the FontLab global font settings that we use to generate the CVT table and the FPGM, the font program, and the pre-program. Those are plain TrueType assembly code written inside the plist, the lib.plist. Inside the .glyph, things get a bit more complicated. The glyph hinting information is stored into the lib part of the glyph, and two keys are added, com.fontlab.tt program and com.robofont.robohint.assembly. The first one is the visual glyph program itself, encoded in base 64. There is a bit of an issue here with the data tag, because it's not really well handled by RoboFab, but it's plist compliant. But we can talk about that later if you want. The com.robofont.robohint.assembly is in fact generated by the TTH from the visual glyph program. So if you make an update to the visual glyph program, it will reflect into the assembly. But don't modify the assembly itself. It's pointless. It will be regenerated by TTH. And the information, this list of instruction in the assembly is directly used by RoboFont to feed the glyph table. That's what we can see here. That's inside the TTF. The glyph table contains the outlines and the instructions we've just seen from the .glyph. The font program FPGM table contains the functions that are ready-made by TTH, and they are the same as the FontLab functions. The pre-program will use those functions, can call those functions, as well as the glyph table as well. And it will also read, the pre-program will read the CVT table and convert the information it contains about the stems and the zones to the pixel size required for the preview. The GASP table is a bit different. It tells the rasterizer how to behave depending on the size range. So I'm done with my part. I would like to thank all the beta testers for their feedback, and especially Tal Lemming, who greatly helped making the interface so nice. Thank you for your attention. I will now let Samuel speak.
So, in my part of the talk, I will focus on three tools that are implemented in this TTH extension for RoboFont in order to help in the hinting process. My notes are mixed. So, the first tool is called AutoStem, and it detects, as the name implies, all the stems, or a big number of stems in all the glyphs in the font, and extract from this a smaller set of typical stem widths that will be stored in the CVT table. The second tool, AutoHint, analyzes the control points in a glyph and generates automatically a visual glyph program that can be used as the starting point for hinting the glyph. Together, the stems and the visual program provide a good starting point, as I said, for the font hinting job. The third tool, AutoMatch, tries to find correspondences between the contours of two different glyphs in order to be able to transfer automatically a visual program from one glyph to the other. So in the context of our program, a stem is defined as a special pair of points, of control points. Let me give some more detail. The configuration of 2 points A and B is defined by their position and their in and out tangents. We should also keep in mind that in a TrueType font, the contours are oriented clockwise, so that the ink or the inside of the glyph always lies locally to the right of the oriented tangents. Now, given 2 points A and B, we say that they form a stem when 3 conditions are met. The first condition is that A and B should have 2 parallel tangents, or almost parallel, such as the yellow and the red tangents here. Then the second condition is that each point should lie on the right side or the inked side of the tangent of the other point. So we can see here that B lies to the right of the yellow tangent and A lies to the right of the red tangent. Finally, of course, the segment AB should be fully inked. It should lie inside the glyph. So in order to find all the stems in a glyph, as defined here, we simply loop over all the pairs of points in the outlines and check if the 3 conditions are met. We then gather all the stems together and sort them into a set of horizontal stems and a set of vertical stems. Here is another example where the pair of points AB forms a horizontal stem, but not a vertical one, and indeed one of the conditions is not satisfied, namely that A here lies locally to the left of the blue tangent. So we have tried, of course, to define those 3 conditions so as to match our intuitive understanding of what a stem is. The AutoStem tool analyzes all the stems that we have found in order to extract a smaller set of typical stem widths to fill the control value table automatically. As you can see in the outline column here. So how does it work? We first gather all the stem widths into an array, and we can see them as a set of points on the number line, as illustrated below. We then use the k-means algorithm to cluster these points into meaningful groups, and then we consider that the mean of each of these groups is a typical stem width, and we store these stem widths into the control value table. So that's how the AutoStem tool works, and you can trigger it by clicking on this detect button in the stem panel. Let us move now to the auto hinting tool, which is used to automatically generate a visual program that can be used as a starting point. It works in 2 steps. First, we analyze the glyph by structuring its set of control points into a 3-level hierarchy. And then we walk down this hierarchy from the top down while generating a visual program. The bottom level of the hierarchy is simply the set of control points of the glyph. The middle level of the hierarchy consists in alignments. As the name implies, alignments are a set of points that are horizontally or vertically aligned. In this example glyph, we have 4 horizontal alignments. The 2 at the top are quite simple and consist in only 2 disconnected control points, and the 2 at the bottom are more complex, since we want to keep the information that some pairs of control points inside one alignment are connected by line segments in the contour. So the bottommost alignment, for example, have gathered 6 control points into 3 connected components. From now on, I will focus only on vertical alignments for hinting along the horizontal axis only, for simplicity of the exposition. So the same glyph here has 13 vertical alignments, and just to try to get to know them a little bit better, note that none of the alignments here have isolated points. They are all the points are part of a line segment in each alignment. And the fourth alignment from the left has two connected components. I can show it with the mouse here. We have one component here and another here. So this is the middle level of the hierarchy. And in order to build the top level of our hierarchy, we abstract these vertical alignments as points on the x-axis. Then we would like to connect these vertical alignments together. And to do so, we use a stem that we have already discovered in the glyph. Recall that a stem is defined by two control points. And whenever these two control points belong to a vertical alignment, we connect those alignments together. So we have formed a graph with the alignments as vertices. And we call the connected components of this graph simply groups of alignments. And these groups of alignments, we have 3 of them, form the top level of our hierarchy. So this hierarchy gives us a structured analysis of the glyph. From this hierarchy, we can start building the visual program. We start by hinting the groups of alignments, and we do so with a simple recipe. We first fix the leftmost and rightmost group of alignments using the left and right side bearings and the 3 rounded single link commands shown here. And if there are any remaining group of alignments, we fix their position using an interpolate command. Note that visual commands actually target control points and not group of alignments. So what we do is that we elect a leader point in each alignment and a leader alignment in each group of alignments. Then all these visual commands here actually target the leader point of the leader alignment of the groups that they are hinting. Okay? Let us move now to the middle level of the hierarchy and hint alignments inside a group. Here, the leader alignment has already been snapped to the pixel grid, so to speak. So we can propagate single links to either sides of the leader alignment, and we add stem attributes to the single links by taking the closest match in the stem widths that are stored in the control value table. We can finally hint each alignment individually by adding single links between the connected components until only one connected component remains in each alignment. We can see here that we have added such single links to the 2 vertical alignments on the left. One here that connects this segment and this one, and another here that connects these 2 segments. We can also recognize in this picture all the visual commands that we have mentioned for building the program for this glyph, so any glyph. So you can recognize the 3 rounded single links at the bottom, the propagated single links with the stem attributes in yellow, and the interpolate command to fix the position of the group of alignments at the top right. Finally, let me give some detail on the auto match tool that we are developing. The purpose of this tool is to transfer a visual program from one glyph, say the glyph on the left, to another glyph, say the one on the right. To do so, we compute a transfer function. A transfer function maps each point of the source glyph to a unique point on the target glyph. And the red arrows here are a partial illustration of such a transfer function. Once we have this transfer function, we can easily transfer a visual program from one glyph to another by simply applying the transfer function to all the control points that are involved in the glyph program, in the visual program. Okay, so this is an example of such a transfer. And now I will give some detail of how we compute this transfer function. We do so in 4 steps. First, we need a way to assess the dissimilarity of 2 control points that belong to 2 different glyphs. Then we use this measure of dissimilarity to compute an optimal matching between 2 pointed contours, which are contours with a designated start point. From there, we can move on and compute an optimal matching between 2 general contours. and then an optimal matching between two glyphs, which can of course have more than one contour. So given a point A on a source glyph, we are looking for the point on the target glyph which is less dissimilar to A. So we define a dissimilarity function called D that should be small when A and B are close and have similar tangents. In the example above, clearly A and B are less dissimilar than A and C, so that D of AB is smaller than D of AC. And in our program, we use this, the mathematical formula shown here that we have found heuristically as a dissimilarity function. But any other function could be used if they share the similar properties. Consider now a source contour at the top and the target contour at the bottom, shown at the bottom here. And these contours are pointed. So each contour has a designated start point, which is shown in gray at the left. A matching is, again, a function that maps each point of the source contour to a point on the target contour. And in order to be able to find an optimal matching, in a sense that I will define very soon, we need two more conditions on this matching. First, is it should map the source start point to the target start point. So the leftmost blue arrow here is mandatory. And second, crossing arrows are forbidden. So the red arrow is forbidden, for example. And the reason for that is that if you follow the source contour in a given direction, and if you walk along the source contour in a given direction, then the matching walk on the target contour should follow the same direction without a U-turn. And this translates into forbidding crossing arrows. Now to each arrow of the matching, of any matching, we associate the dissimilarity between the 2 points that the arrow connects. And we define the score of a matching, of a pointed matching, as the sum of those dissimilarities. We have framed the problem in such a way that now we can find the optimal matching, pointed matching, that is the matching with the lowest score using dynamic programming, which is a very well-known and very useful tool optimization technique in computer science. So we have optimal matchings between two pointed contours. Now when we have two general contours, we can simply fix arbitrarily a start point on the source contour and try all possible start points in the target contour. For each pair of start points, we find the optimal pointed matching between the two pointed contours, and then we simply pick the pair that gives the lowest score. And we get an optimal matching between two contours. I'd like to also mention that there is no need to have the same numbers of points in both contours. So now let's move on to matching two glyphs that can have more than one contour. To do so, we assign colors to each, in its conceptual view, we assign colors to each contour in the source glyph, so that the problems now becomes the one of finding color assignments to the contours on the target glyph that gives the lowest score when we match the contours having the same colors in the source and in the target glyph. So luckily, there are usually a very small number of contours in a glyph, so we can try a brute force solution. We simply try all the color assignments to the contours of the target glyph, and for each color assignment, we compute the sum of the scores of the optimal matchings between the contours having the same color in the source and the target glyph. Then we pick the color assignment that gives the lowest overall score. So now our transfer function is ready, and we can apply it to transfer any visual program from a source glyph to the target glyph. So let me end with this simple example of a successful transfer between two weights of the same font family. That's for hinting in the y direction here. To conclude, I'd like to mention that you can ask for a beta version of the TTH extension by visiting this website, typosampon.com. You can download the quadratic converter utility on GitHub or install it via the mechanic extension. And finally, our affiliations. Jeremy is working at Type Factory, and I'm working at INRIA. And here is our respective web pages. Thank you.
That was awesome. Dissimilarity functions, I think, I want to have on a t-shirt. All of this stuff also applies to interpolation and finding masters and finding matchings, and so we'll be hitting reload on those pages every day, I think. Thank you very much. This concludes the first day of Robothon. I thank you very, very much for coming and your attention and staying awake in a less than optimal oxygenated place. This evening, remind you, is a party at Bureau Peter van Blokland and Claudia Mens, sponsored by my brother Peter van Blokland and the Font Bureau. If you do not know how to come to Delft, find your travel buddy. Find him now. If you don't have one, get one. And I will hear about the reference later. 8 o'clock, dinner is on your own. You can find good places to eat here in The Hague. Ask a TypeMedia student for ideas. There are trams to Delft. I think there are also trains to Delft that arrive in the beautiful new underground train station, where apparently it's so new that when the trains go through the tunnel, the revolving doors start spinning because they haven't, which is really nice. Tomorrow we start again 9:45 because I was thinking you probably want a quiet morning. We also did not want to give the earliest slot to everybody. So tomorrow morning we start with Rainer Erich Scheuchelbauer. Any questions? No? Maybe I'll see you this evening at Peter's, otherwise we'll see you tomorrow morning, and thank you for coming. Thank you.